Ever wondered how Starlink brings high-speed internet to the farthest corners of the globe? This video takes you on a journey through the fascinating world of satellite internet, showcasing how thousands of satellites in low Earth orbit work together to provide seamless connectivity. From the launch of satellites to users enjoying fast streaming at home, we illustrate the technology that bridges the digital divide. Discover how easy installation and user-friendly apps make high-speed internet accessible to everyone. Join us as we envision a future where opportunities are just a click away, no matter where you are. Point 1. Introduction to Starlink, overview of SpaceX and its vision. The purpose of Starlink, global internet coverage. The importance of satellite internet in underserved areas. 2. The technology behind Starlink, low Earth orbit LEO satellites versus geostationary satellites. Design and operation of Starlink satellites. Communication between satellites and ground stations. 3. The Starlink constellation, phased deployment of satellites. Number of satellites required for global coverage. Orbital mechanics and satellite placement. 4. Ground equipment. Starlink user terminal Dishy McFlatface. Router technology. Power requirements and setup process. 5. How data travels, signal flow, from user to satellite to ground station. Laser and terse at-light links ISL for reduced latency. Role of gateway stations and network operations centers. 6. Starlink network performance, speed, and latency benchmarks. Impact of weather and obstacles. Scalability and capacity considerations. 7. Challenges and solutions, space debris and satellite collisions. Regulatory and licensing hurdles. Addressing light pollution concerns. 8. Comparison with traditional internet providers. Fiber optics versus satellite internet. Advantages of LEO satellites. Affordability and global accessibility. 9. Applications of Starlink, internet for remote areas. Support for disaster relief operations, role in military and government communications. Connecting vehicles, for example, planes, ships, RVS. 10. Environmental and ethical considerations. Sustainability of mega constellations, mitigation of environmental impacts. Balancing global connectivity with ethical concerns. 11. Future of Starlink, planned improvements in hardware and software. Expansion to Mars and beyond. Integration with other SpaceX projects, for example, Starship. 12. Conclusion, summary of Starlink's impact. Challenges ahead, vision for a connected world. Here is the detailed version for each heading. 1. Introduction to Starlink. Starlink is a satellite internet service developed by SpaceX, a private aerospace company founded by Elon Musk. The project aims to provide high-speed internet to every corner of the globe, particularly in remote and underserved areas where traditional internet infrastructure, like fiber optics, is impractical. Real-life example. Imagine living in a small village deep in the mountains. Traditional providers cannot install underground cables to your home due to the high cost. Starlink solves this by using satellites to deliver internet directly to your home, regardless of the terrain. 2. The technology behind Starlink. Starlink uses low Earth orbit LEO satellites to create a network or constellation of interconnected satellites. Unlike traditional geostationary satellites that orbit at 35,000 kilometers, Starlink's satellites orbit at just 550 kilometers. This reduces latency significantly. Analogy: picture a race between two delivery services. One uses a plane flying at high altitude geostationary satellite, while the other uses a drone flying much closer to the ground LEO satellite. The drone delivers packages much faster because it has less distance to travel. Key components: satellites equipped with solar panels, antennas, and propulsion systems. Ground stations act as relay hubs connecting satellites to the internet backbone. User terminals, small dish antennas that users install to receive signals. 3. The Starlink constellation. The constellation refers to the network of satellites working together to provide global coverage. These satellites are launched in batches using SpaceX's reusable Falcon 9 rockets. Analogy: imagine a fleet of drones delivering packages across a city. To cover the entire area efficiently, they operate in predefined routes and work together to ensure no region is left out. Key facts: number of satellites. Starlink plans to deploy over 42,000 satellites. Orbit: satellites are placed in different orbital shells to optimize coverage. Phased deployment: initial focus on high-demand regions, later expanding globally. 4. Ground equipment. The user terminal, often called Dishy McFlatface, is a small dish that connects to Starlink satellites. It's easy to install and automatically adjusts to track satellites. Example: so think of it like setting up a TV satellite dish. But instead of watching TV channels, your dish connects you to the internet. The router included with the system broadcasts Wi-Fi in your home. Key features: self-aligning, no manual pointing required. Weather-resistant, can handle snow, rain, and extreme temperatures. Portable, useful for RVs, boats, and remote expeditions. 5. How data travels. When you use Starlink, data flows from your device to the user terminal, then to a Starlink satellite overhead. From there, it's relayed to a ground station, which connects to the broader internet. Analogy: imagine sending a letter. Instead of handing it directly to the recipient, you give it to a messenger, the satellite, who passes it to a sorting office ground station, and then it reaches the recipient. Laser Intersatellite Links ISL. Newer satellites are equipped with lasers to communicate with each other, reducing reliance on ground stations and improving latency for long-distance data transmission. 6. Starlink network performance. Starlink offers high-speed internet with low latency compared to traditional satellite services. Typical speeds range from 50 megabits per second to 250 megabits per second, with latency as low as 20 milliseconds in optimal conditions. Example: as if you're playing an online game, latency determines how fast your actions are reflected on the screen. Starlink's low latency makes gaming and video calls much smoother. Factors affecting performance: weather. Heavy rain or snow can reduce signal strength. Obstructions, trees or buildings blocking the dish's view of the sky can cause interruptions. Network load. Speeds may vary depending on the number of users in the area. 7. Challenges and solutions. Space debris. With thousands of satellites in orbit, the risk of collisions increases. Starlink satellites are equipped with autonomous collision avoidance technology. Analogy: imagine a busy highway. Starlink satellites are like self-driving cars that can automatically change lanes to avoid accidents. Regulatory challenges. Different countries have strict rules for operating satellites. Starlink must obtain licenses to operate in each region. 8. Comparison with traditional internet providers. Starlink competes with fiber optic, DSL, and geostationary satellite providers. While fiber offers faster speeds, it's limited to urban areas. Starlink excels in remote locations. Example of fiber internet is like a high-speed train on fixed tracks. Starlink is like an off-road vehicle that can go anywhere. 9. Applications of Starlink. Remote areas, providing connectivity to villages, islands, and ships. Disaster relief, enabling communication during hurricanes or earthquakes. Military use, secure communication for defense operations. Example: after a hurricane, traditional communication lines might be destroyed. Starlink dishes can be quickly deployed to restore connectivity. 10. Environmental and ethical considerations. Starlink has faced criticism for light pollution affecting astronomical observations. SpaceX has introduced dark coatings on satellites to minimize reflectivity. Analogy: think of a city installing streetlights with shields to reduce light spilling into nearby homes. 11. Future of Starlink. Starlink plans to upgrade its technology with faster satellites, better ground stations, and expanded coverage. There are also ambitions to integrate Starlink with SpaceX's Mars missions. Vision: imagine astronauts on Mars using Starlink to communicate with Earth in real time. 12. Conclusion: Starlink represents a revolutionary step toward global connectivity. While challenges remain, its potential to bridge the digital divide is unparalleled. To ground each section in the context of futuristic developments and advancements, I'll build on the existing details and explore how Starlink's current technology and approach pave the way for broader innovations. Here's the elaborated version. 1. Introduction to Starlink. Starlink's mission to provide global internet access is not just about connectivity today, but about laying the groundwork for a future where the internet is a universal utility as essential as electricity. The vision aligns with humanity's increasing dependence on digital infrastructure for education, healthcare, business, and governance. Futuristic grounding, global equality. Starlink helps bridge the digital divide, ensuring that future technologies like AI-driven education or remote healthcare reach remote areas. Support for IoT expansion. As the Internet of Things IoT expands, Starlink's coverage can connect devices in rural or extreme environments, such as agricultural sensors in remote farms or weather stations in the Arctic. 2. The technology behind Starlink. By using LEO satellites, Starlink has already changed the satellite internet landscape. These satellites are equipped with advanced propulsion systems and communication technologies that can evolve into a backbone for futuristic applications like autonomous vehicles and space-based data centers. Futuristic grounding, autonomous transport. Satellites can provide real-time data to autonomous ships, planes, and cars, enabling safe navigation even in the most remote regions. Space-based computing. Future advancements may involve computational satellites performing tasks like climate modeling or AI processing directly in orbit, reducing dependency on terrestrial data centers. 3. The Starlink constellation. The modular design of the Starlink constellation allows for scalability and upgrades. As thousands of satellites form an interconnected web, they lay the foundation for a truly global communication network that can support emergent needs like interplanetary communication. Futuristic grounding, interplanetary connectivity. A similar constellation can be deployed around Mars or the Moon, connecting future space colonies. Global Emergency Network. A fully operational constellation could act as a fail-safe communication network during global crises, such as cyber attacks on terrestrial infrastructure. 4. Ground equipment. The user terminal's simple design is not just about convenience today, but sets the stage for portability, automation, and adaptability in future applications, such as connecting vehicles or mobile operations. Futuristic grounding, portable internet for autonomous robots or drones operating in disaster zones or space missions can use Starlink terminals to stay connected. Edge computing integration. Future dishes could include edge computing capabilities, processing data locally and reducing latency for critical applications like telemedicine. 5. How data travels. The advanced data relay system Starlink employs, especially with laser and Tersat light links ISALs, sets the stage for fast, resilient, and secure data transfer systems that can handle futuristic demands. Futuristic grounding, quantum communication. Starlink's infrastructure could integrate quantum encryption technologies, ensuring ultra-secure communications for governments, militaries, and corporations. AI-optimized routing. Machine learning algorithms could dynamically optimize signal routes through the constellation, adapting to user demand and environmental conditions in real time. 6. Starlink network performance. Starlink's current speeds and latency are already groundbreaking for satellite internet, but future advancements could make it competitive with fiber optics or even faster. Futuristic grounding, 5G and beyond. Starlink could complement terrestrial 5G networks or even provide the backbone for 6G by offering high-speed, low-latency connectivity in areas where
Thank you for watching. We're always happy to have you here. Please do subscribe, like and press that bell icon for us to notify you for our upcoming amazing videos. Also tell your friends and families by sharing this video. Remember, sharing is indeed a caring. Thank you again, and until the next video, have a good one.